bit late, and also for my voice, my throat hurts a little bit. Hope you're having a good day. Sun is shining, and accordingly, we want to do some apoc fun. If you have questions, please bring them along, and let me know where you're listening from or watching from. I'd love to say hi, and also it's always nice to see where people are coming from. I want to show today some of the lesser known apoc things, but what I want to start with is actually some cool news. I also had to restart my computer, so because the keyboard was not working anymore. So some of the stuff I need to go and find first. So what I wanted to show you first is we have actually really cool new documentation for apoc and labs in general. So the docs and labs documentation on neo4j.com has been revamped, and now we have the developer guide, but also the labs docs in a nice new format with some really cool improvements. So one is you can edit the pages, so you can actually submit edits and improvements. So if I do this, basically it gets me to GitHub to the page, and I can send a pull request. So if you spot any typos or improvements, or you want to add an example to something, then please do so. And then there's also was this page helpful? Yes, no, and if no, you can also add an feedback, detailed feedback as well. So please use these features to give us feedback as such. Something else that has changed for apoc, actually several things have changed for apoc. So one thing that we built and added, which is really cool, is now each procedure and function has its own page. So first of all, the overview changed a little bit. So it's more structured into sections, and each of the sections should be easier to read than the original table. You also see immediately is it a function or a procedure. And then if you click on one of these, you will get a detailed page, so which would also be better for Google to find. You can copy things to the clipboard and run them directly partially as well. So that's really nice. Something else that's new that you might have not spotted before is that there's now something called apoc core and apoc full. It's also visible if you go to apoc releases. There we now release both the core jar and the all jar. So the core jar is something that, starting with neo4j 4.11, is bundled in a download. So for instance, if you download neo4j, download center, then if you don't need any of the functions or procedure that are in the extended package or in the extended packaging, then you can just take the apoc version that comes with the binary. So if I just download neo4j server, let's see, I just download the tar for time being. But it should also be in the other binaries, so in the Debian and RPMs and so on. Even on the desktop version, that's actually a really good question. So I just created a database on desktop, and if I open terminal to this installation, I now see there's a labs folder, and in this labs folder we have the apoc core jar. So that's always the right one for this neo4j version. And in the README, you have also an explanation about what this is about, and that you basically need to copy this apoc core jar into the plugins directory. And optionally, if you want to use the sandbox procedures, you have to put them into unrestricted. But you need to be careful because if there's already an apoc library and plugins, you must not have both. So there's only one apoc jar that must be in the plugins directory. If you have two, then they will conflict, and it will like all hell will break loose. So please don't do that. But even if I just download the server here and untar it, there is the labs folder with the apoc jar in that download as well. So that should make it easier for people that don't know where to get the right apoc version for their release. And that also explains what this core and full means. So that's the release that it's in. So, and some of the features that are less common we want to look at today, or that have not been explained as much. And I can do both. So I can use a sandbox, like for instance here the recommendation sandbox, which I recently updated to have some more fun data in there, like posters and more details about actors. And locally, I just created an empty database, installed apoc via the UI, and added the apoc file enabled and input file enabled things here. So it's already running. So we can start browser by just pressing Command K or Control K and say open Neo4j browser. And here's the first one that I want to show you. So as you know, or as you might know, Neo4j's user-defined function procedures are usually written in Java. So not everyone is a Java developer. And sometimes there's also just a quick cypher snippet that you want to turn into an user-defined function or procedure. And that's something that you can do with apoc. Just quick hello. Hi, Daniel from Switzerland and Jonathan from France. Nice that you're watching. If you have questions around apoc, please bring them on, and happy to answer them. So here's a really super simple example. So we can declare functions and we can declare procedures. So there are two versions of this. So there's an S function and S procedure, which was the first implementation of this, which takes a more complex set of inputs where you have to define inputs and output parameters and types separately and so on. And what we can do now is basically just use the signature. So I had the idea, why can't we just use the signature? So you know that as you saw just here, if I look at a procedural function, I can get a signature here, and why shouldn't we be able to use the signature to define a function or procedure's signature? So what I did basically is I wrote an parser for the signature, and I use that to define a procedural function. So you can, for instance, say I have an hello world function, and it's called hello, but because in Neo4j there must be a namespace for functions and also for procedures and also for safety reasons. So I didn't want anyone to override built-in procedures or functions. So everything is get a custom prefix. And if I now use custom hello, it should return hello world, right? So if we were to override it, so this is now where it gets interesting. We can input a parameter here. So I hope this works with the overriding. If not, then we need to give it a different name. And now the parameters are passed in as procedure parameters, cypher parameters. So if I say hello $who, it should hopefully work that we now have a call dbms functions or call apoc custom list, and it has a bunch of entries, and this is the one that we're looking at. The first one was something where I messed up something, so let's see if this works or not. But we can also call dbms.functions yield name comma signature, where name contains custom hello, and return star should give us our new function here. I'm not really sure why it has two entries, so that's something that we need to check, or why it has even more entries. So okay, that's something that I need to check. But if now I do custom hello, for instance, Daniel. Let's see if this works. It doesn't like me. Okay, so then let's try to do hello too. So I have to check what's happening there. So it says hello Daniel. So you see that you can pass in parameters to these functions, and the same is true for procedures as well, right? So where a function returns a single value, a procedure would return a stream of values. So we could also say custom declare function, declare procedure, and then we can say, for instance, I want to see all people in this graph, right? So that doesn't take a parameter and returns nodes, right? So and what I can do now is I do just match person return p should give us a list of people, right? So I hope I didn't misspell anything. Let's see. It doesn't like me. People node. So I did something wrong. Do I need to put custom in front of this? Don't think so, right? Okay, so I'll have to check the log. There were some changes in 4.x that might have broken things, but in general, you could just use this and then you get basically a named Cypher procedure with optional parameters that you can use later. So this is one feature that I wanted to show you today. The other one is actually something that's open here already, which is aggregation function. So you know that you can do aggregation in Cypher. Yeah, similar. So this is similar to function and store procedures in SQL. So Neo4j's traditional functions and procedures. So if you go to Neo4j procedures functions, there is the ability to implement stored procedures in Java. So basically, so you can say, give me a name and a parameter, and the implementation is actually a Java method that has an annotation. That's a test. Where's the actual code? We have the plugin project here. So and the code looks like this. That you would basically implement this in Java. So for instance, this one here, where you have an annotated method with a procedure annotation, and that implements the procedure. And what we did in apoc, we added the ability to also define procedures on the fly, basically based on Cypher, right? So this is just Cypher. This is not like Cypher script or something like that. So this is just Cypher. It currently is only also just one Cypher statement. So if you want to do something more complex, you would have to use union or subqueries or things like that to compose more complex things as such. But it's still quite handy, and I just need to figure out what's went wrong here. But I'll do that later. Cool. The next thing that I want to show is the aggregation things. So as you know, Neo4j has a bunch of aggregations. So for instance, in my recommendations graph, I can just do things like I can do things like this. Come on. Here I have a ton of actors and people and so on. So I can, for instance, say, give me person return count star, right? Give me all the people. That is 19,000 people, and I can group this by, for instance, by p dot I think born by year. So I get all the people and when they were born. Or that's the birth date. So I actually wanted just to have the year, so I can say substring of p dot born, or I this is actually in p.1.year. Let's see. Yeah. So so these are the people by year, and now I could say as year, and then say for instance order by year or order by count. So like this is basically 2018 are 6 people that are born in this graph. So and what's interesting, there's a really cool function, aggregation function called collect, which basically gives you the people. Let me see where exists p.born. So which gives you the aggregation as a list, basically, right? So it aggregates not as a sum or count or average, but it gives you the things as a list. So imagine we wanted to have the first name of per year of these people, right? So I could do something like with p order by p.name. So we have names in ascending order. So that means our lists are also in ascending order here. Come on. There, right? So it starts at A or space A here even. There's lots of people that have like a space in their name, so we need to fix that data, I think, as well. So and so if you only want to have the first one, we can use these slice operations in a list and say we do the collect, but then we only take the first element, right? So we pick the first one from that list. So now for each year we get the total count, but we get the first element in the list here, right? So that's either space A or it's kind of the font is weird, so I'm not 100% sure. Looks a little bit weird. Yeah, there's some space in front of that, so I need to fix this data. I don't know why. So the source data is a little bit buggy. So, but of course this is quite expensive because we have to collect these lists first and then pick the first element. And that's where some of the apoc aggregation functions come in. So we can just use apoc ag first. And this should give us the first value out of the box. Right? So if you do apoc aggregation first, it should give us the first aggregation function and the first value of the list automatically. There's also last, of course. Which gives us the last value. There's also nth. So if I want to have the second or so, I just use nth. So zero-based lists. So that's the second value in the list. Then we also have slice, which then gives you an from to, so 2 to, let's say 4 or something like that. And so that should give us either 3 or 4 values. I can't remember right now. So that gives us 4 values. So length is 4. Right. So these are some of the aggregation functions which are quite nice. There's also some others like numeric ones like median, min items, and things like that. So which are more involved. Percentiles, you can specify which percentiles you want, right? So you can do products, slices, and statistics. So if you look at percentiles, for instance, we can get the percentile distribution of the years, for instance, right? So let's see. Return, we could, for instance, do sum of p.1.year. So what's the sum of the number of years that people have been born in? It's a pretty large number. We can, of course, it makes more sense to have the average. The average here. So it's 1951, so pretty old actors in our graph. But when we use apoc percentiles, we can actually provide a list of percentiles that we're interested in. So we can say we want to have 50% percentile, 75% percentile, we want to have the 90% percentile, and the 95 and 99% percentile as right. So it should give us this. So the 50% percentile is 57. So you see that most people are in there, and the 99% percentile is 1996. So it's still very old. But I guess for an actor, you have to have lived for a while. So there's also statistics, apoc statistics, which gives us even more, which gives us also min, max, total, standard deviation, and so on. So we get all these numbers. So what's the min, what's the max number? 1649 is the oldest actor that we have. That's a really old actor. Which also affects, of course, our mean. We see the standard deviation and so on. So that's quite useful. And here are also all the percentiles. So if you want to do things like that, feel free to check out the aggregation functions. Something that we showed last week or this week in Sum of Nodes is the routing function. So if you want to do geo-routing, you can use A star or Dijkstra, for instance. That's really useful. So if you want to see more of that, there's a blog post on Medium that goes into some of these details. Sum of Nodes, and has a sandbox actually with OSM data that you can use for looking into that. So I definitely recommend this as well. The other thing that I wanted to show you is the so I already talked about virtual nodes and relationships in some other ways. Something that's really cool that I have not shown before is apoc.bolt procedures. So basically that's procedures that can connect to another database. So you might remember that we have database integrations with Mongo, with JDBC. Go away. Why doesn't it go away? I think I found a bug. Okay. Database integration is probably an import. From web APIs, Excel. Here, database integration, sorry. So we can load stuff from JDBC databases, we can load things from Elasticsearch, from Mongo, from Couchbase, from LDAP, and also from other Neo4j databases. And that's actually a fun one. So we have a bolt.ul, and we can use that to connect to a remote database. And what we can try to do is we take our example here and use this with our sandbox database. So we have our sandbox running, right? So we can find here in the connection details our bolt.ul username password, and we have our local database which is currently empty, and we can use apoc.load bolt, and then the user is neo4j. And password and bolt.ul is this. So that's the bolt.ul. And our password is, what was it, 90s sans amount. So and then we have our people in there, so we can actually say, for instance, we want to have all people where p.name starts with, and then we just use prefix, and then we can pass in a prefix here as a parameter, just to show you what it looks like, right? So return p limit 20 or so, right? So, and if you execute this and everything works, then it does a bolt connection. Yay! does a bolt connection to the other database and returns the data from that other database. So this database is still empty here, so I'm not cheating, right? So this is empty. So we're actually extracting data from the other database. And now we can create the content. But what's actually cool about these bolt procedures is that we can show them as a virtual graph. So there's in the config, we can say, where's the config? You can also externalize, of course, like in all the other database things, you can externalize this into apoc.conf and put this in here, and then you can say, I used just the name for the URL. Yeah. And what's cool is we can say statistics, so that would execution statistics, and virtual gives us a virtual graph of the data. So if I do config virtual true, and it works, yay! So we see our nodes with their labels returned from this other database, and our database is still empty. See? And if you were to return like a full path, for instance, a person is acted in a movie, then it should also return the relationships as a virtual graph. Let's see, does it do this? Return not piece but path. Yeah, so we see the data from our other database, and now we can, if you wanted to, create the data in Neo4j. And with bolt.execute, you can also write to other databases. So if you have permissions, if your user has permissions to write, then you can also write to this other database. All right. So what we need to add here in this, currently it connects only to the default database. So we need to add a config option that says which multi-database it should connect to. I just realized this. So, and to not forget, we just added as an issue to apoc. Feature request add database name to apoc.bolt.load as URL context path or in config. Okay. So that's a really interesting one as well, and the next one that I wanted to look at is where's the other one that I wanted to look at? Oh yeah, the export one, right? So you know that we can export data from import data from web APIs, for instance. So that's something that I quickly want to show as well, which is load. Where's the what? I just need to use. Oh, I did this on the other machine. Okay. So if you have a web URL, we can just load data from there. I showed this in the past for Stack Overflow. So in Load.json, there's an example for loading data from web URLs. So we can just take data from somewhere and load the JSON, CSV, Excel, XML, and so on. There's also an HTML loader, which is kind of fun. And there was recently a blog post from, I think from Mark, who showed how to do the load HTML based on Wikipedia data, I think. But what's actually more interesting is, imagine you have a cloud database, and usually we would do something like locally we would do a call apoc export JSON query, and then we can provide a query, for instance, match p person return p limit 10, and I give it a file name like people.json or something like that. People.json, right? So I can do this usually, but of course if I have a remote cloud database, like in this case with my sandbox, it complains that JSON query. Oh, file is the second parameter, sorry. My bad. So, hi Kiran. If any of you has questions around apoc, please let me know. So if I want to export this here, it complains that apoc export file should be enabled. And also it doesn't help me that it writes so for security reasons, of course, you don't want it to write on your server that runs your database. But also it wouldn't help me because the file resides on the server and I would need to have SSH access to the server to get the data out. So what we added actually is the following, that you can stream the results back to your client. So that means if I don't pass a file name and say stream true, what it should do instead is it should return me the JSON stream statements. Should just be stream true, or it could be something that we didn't fix in the older version of apoc that's here on the sandbox. So let me just try this locally. So we can actually do a combination of what we had before. So we have the apoc.load.bolt here that returns these maps, right? So it returns this yield row. We just say create p person set p equals row, just to have a quick one. And we could of course use it's probably better, we use call apoc create node, and then we say row.labels are our labels and row.properties are our properties, yield node return node. So this should be now creating like a bunch of nodes in our database, hopefully. But something went wrong. Prefix, so we have we have p. Oh, sorry, my bad. So it's actually nested. So because this is like in the row, there are different columns. So it's actually row.p. Because you could have like p and n and m, of course, in return. Okay, so let's try this again. Now we're talking. So now we created basically data from our other Neo4j database with a single statement, right? We have these actors with these labels and so on. So if I now do the call apoc.export.json, we can now actually also use all without the query, but let's still use the query. So match p person return p, and then I can put in people.json because I actually here locally enabled file export. It should actually have created in my import folder people.json. So you see this is kind of streaming JSON, so this is JSON lines. If you haven't seen that, there was a question this week around why this is not regular JSON. And the answer is basically for streaming large volumes of data, JSON is not so great because you have to build up the document structure first. And of course, apoc supports streaming JSON in, but many other tools don't deal so well with like millions or hundreds of millions of records in your JSON. So that's why we have JSON lines, so where each line is a JSON object, right? So each of those is a JSON object, and so we can use that for exporting the data, right? So we can also, if you use apoc JSON export all, where's my browser here? If you do all, then it actually does reload. It basically does each node on one line, and all the relationships would have type relationship and then like all the data in there. So which is really nice because you then can stream process this again. And there's also the counterpart, which is called apoc.import.json, which basically takes these files and turns them into a graph again. So you can get a round trip from A to B. Hey, Abdulwahab, the apoc library is available everywhere. So you can get it in Neo4j community, in Neo4j enterprise, in Neo4j Aura, in Sandbox. In the Docker image, there's a really easy way of getting apoc as well. So if you go to Neo4j Labs, you have, or if you Google for apoc, it's there immediately. So you have a lot of content there. But you can also get access to the documentation. And here you can also, if you want to get the releases for the different versions of Neo4j, you always have to watch out that the first two version numbers match with the Neo4j version. But that's also all explained in the documentation. So if you go to the documentation here, then installation is also explained here. In Neo4j desktop, it's a single click install. So you go to plugins and click install. In Sandbox and Aura, it's there out of the box. So it's also explained here again. So you can use it. It's like the standard library for other tools and languages, because we put in all the things that people wanted to have in Neo4j and Cypher and that weren't there, but that we felt were really useful. We put them into apoc. So that's why the docs are really big and comprehensive. And I recommend, if you haven't seen them, have a look at the docs as well. And there's an apoc help procedure that can give you keyword-based help. So you just put in a keyword and it shows you all the procedures that have this keyword in its name or description. And there's also a bunch of videos. I created an apoc video series, so if you want to learn more there, then you can also look for this playlist as well, which is also linked on the page here, which also has like the video playlist and so on, right? So you can go there. Okay, I was speaking about the JSON lines on apoc import JSON, which is kind of the round trip in the other direction. So if you do apoc import JSON, there's this one here. Apoc import JSON is used for the round trip from the other way around. But imagine my local database wouldn't be a local database where I can just write to a file, but would be a cloud database. So I can't run this actually against, can't write a file. So what I can just say instead, I want to don't pass in a file and say stream true, and then it basically gives me in data, so I can just do yield data. It gives me the content here in data, which is really nice. So I can basically get this streamed back. And if I connect it to Neo4j via Cypher shell, so imagine I have here my Cypher. Let me just make it a little bit bigger. I hope you can read this. Bin Cypher shell. Hello. to localhost, username neo4j, password is test. So if I run this here, I can basically say connect to this database, run this query, and then I get like all the data back, which is not so helpful because it's kind of in this escape format. But if I do it from the outside and say I want to run this statement and pipe this into this shell and say format plain, I should, oops, yield data, wasn't it format plain? So we can say format plain, oh dash format, sorry. You can also pass params from the outside, you can pass in a file with your cypher statement. And did it actually support? Oh, we can also write just the cypher behind the shell, right? So I can also just take this, put it to the front, and just do it like this and do format plain. I mean, it's not so helpful because of the long prompt here. But you see, I call it cypher shell, say format plain, and then my cypher statement, and if I run this, I get this data back directly. Right? So that's really nice. I still have to unescape it, as we can just see, but that's really useful. We can do the same for apoc.export cypher, which then turns our database basically into a cypher script. Yield statements, I think is the right. Apoc.export cypher all. Just need to check what the cypher statements. It's called cypher statements. Cypher. So if you connect to a remote database, then you basically can get all the stuff back as a cypher script file, which you then can execute locally again. Abdullah has another question. So apoc library would be the best choice for taking a huge JSON payload and turning it into Neo4j. Yes. So there's actually, if you have a streaming JSON, that would be best. So if it's like one object per line, but it can also deal with other JSON formats. It also has support. Apoc has also support for JSON path. So you can in apoc.load JSON, you can just point it to an URL. You can optionally pass in a JSON path, which is similar to an XPath, and config options. And then with the result, you can create your data. And you can combine this as well with periodic batching. So imagine we got an API that returns like let's say 10 million 10 million JSON items in one go. Then you would split this up and would do something like this. You would do something like this here. Or I can also show it in browser. Here's my browser. You would do something like this. You would do call. Let's make this a little bit bigger. Call apoc. Come on. Periodic iterate, and then you have multiple statements here. So the first statement provides the data. So in our case, it would be call apoc.load JSON. Here we pass in our URL, and then we say yield value, or we don't even need to do this. Apoc.load JSON URL. And the second statement is basically creating your data. So it would be, for instance, merge. What do you say? GitHub jobs, and you would say, okay, I have value.id. So this actually does a yield value return value, right? So value is available in the second. So you merge the job on ID, and then you would say on create set j plus equals value dot data or something like that, right? So and then you can say, okay, I want to batch this. So you can say batch size is 10,000 or so, parallel true or not. So for nodes you can make it parallel. For relationships I would not make it parallel. And then if you run this, it would actually create the data in a batch fashion. You have to watch out, of course, if you pull things from APIs, you might need to throttle stuff, because otherwise you run in API limits. So there's another cool function that a colleague of mine added to apoc, which is if you have to do multiple calls to apoc.load.json. For instance, if you have something like here, we have the MovieDB API. So you have, for instance, an API overview. Give me where's it? API overview here. So you have basically something like search, where it gives you all the movies and actors of a certain type. So there's like, where's it here? Search is here. So you can search for something, and then it gives you like all the elements. And then for each of the elements, you need to do an, for instance, movie or person request, which then kind of every time hits the API, and for some API gets you into like API rate limits and throttle. So there's a function in apoc which is super helpful, which is called, where is it here? No. Apoc documentation. Actually, we can just Google for it. We can just say apoc util sleep. So that allows you to pause execution for a number of milliseconds. Basically, you say, okay, I want to sleep for 500 milliseconds or something like that. So you can, in between API calls, you can also add a sleep, so you're not exceeding rate limits as well. If you pause first with Python, then you don't need apoc as such, because then from your Python you can just call with the Bolt driver. So if you go to neo4j.com, developer Python, you see the example code, how you would connect to neo4j and create data through this. And what I would do instead here is I would batch things. So basically, if you use Python, I would use something like this here. I would use basically unwind. So in rows is basically a list of dictionaries, right? So you basically batch in your Python code your jobs, ID1, name, something, and so on, right? So and then you have the second job with ID2 and so on. And then what you do in your Python code, you pass this batch of rows, so like 10,000 or so, into the cypher statement when you execute it, and you do it to unwind rows as row, and then you do merge jjob ID as row.id. And then basically on create set, for instance, job.name is row.name. So that's what I would do from Python, right? So in Python you just then do tx run. So you do session, write transaction, and have a lambda here that gives you tx. And then you do tx run of this code, basically, and pass in rows is your, so something like this. Right, so that would be like your Python code, more or less. And then you batch it over the list. right? Hey Jonathan, thanks for the praise. Yeah, I'm happy to help. And if you have any questions, feel free to reach out either in our Twitch sessions, or you can also reach out on Slack. So if you go to neo4j.com Slack or to community.neo4j.com. So we're happy to answer questions there as well. But if you have anything, Jonathan, feel free to ask as well, because that's what these interactive sessions are for, is to give the opportunity to answer questions directly, right? So Abdul, I hope that helped you a little bit. And merge helps you with the uniqueness, because what you would do also, you would create a uniqueness constraint. So you would say create constraint on jjob as j.id is unique. So that's what you would do first in your database, and this merge on the job ID then guarantees that each job is only created once, right? So take a screenshot of this, or you can see it later in the video as well. I can't copy and paste it into the chat, unfortunately, because I'm running the chat on the other computer. So I can perhaps do it later, that I send it over and put it in. I can just put it in code somewhere here. Okay, so we have 5 more minutes. Let's look at some other cool apoc stuff that we can do. There was something else that I wanted to show. So the streaming is really cool. You can load data from Excel, graph updates, temporal. What was the other thing that I wanted to show? Good. So I think the other thing that I wanted to show is a little bit of graph refactoring. So imagine I have my nodes in my database here, and I want to change this a little bit, right? So for instance, I have let's say I have all my people here, and each of these people might have a not a country, but an oh yeah, let's do this. So all our movies have like an array of countries here. So what I can do is to say, here's my movie. Here's my movie. So our movies have languages and also countries. Here you see countries, right? So imagine we wanted to create nodes for these countries, for the movies, and connect them. So what you usually would do is I match the movie where exists m.countries, and then what you can do is you can do unwind m.countries as country, and then say merge the country node, and then create a relationship between the movie in country, right? Imagine you have a lot of movies, then of course you don't want to, let's say it's not just 20,000 or whatever, but it's like 100 million or so. Then you would do apoc periodic iterate. So you could say apoc periodic iterate, and have 2 statements. So one is our first data statement that provides the data, which is just find us the movies, right? So we just say where exists movie, return m. And then our second statement is takes the countries, merges the country, and connects the movie, right? So And then I can say my batch size is, because I don't have so much data here, I just use a smaller batch size to show you. Batch size is, let's say, 1000, and I can say parallel true or false. But for our example, we don't need parallelism here. So, and the only thing that we also need is, I would also create a constraint on country assert c.name is unique. Come on. A little bit of network lag. So, and if we run the statement here, you see that that our first statement provides the data, so in our case the movies that we want to change, and then we turn the countries into their own node, connecting the movie to the country, and we can also remove now, if we wanted to, the countries field from movies, right? So, and if you execute this, it shouldn't take long, it's only a few thousand movies. And then we should see country popping up here. And then what we see here is how many batches. So it was 10 batches total, 9,000 nodes, 4 seconds, no failed operations. So if there were failed operations because I made a mistake somewhere, then you would see these failed operations here, and also error messages as well. And you also see kind of details as well here. So for instance, imagine I made a mistake, and let's say I misspelled the name here of something. Let's say I would say country here. Then I would get instead get execution errors. So you would see them as well. Come on. So it would say, okay, there's an error in the cypher statement, so everything fails then, right? But now we have our countries, and our countries are then connected to our movies, right? So we can basically see, if you look at the movie, then which countries are connected to. And so periodic iterate is super helpful, means not just for inputting data, but also for running graph refactorings on larger scale as well. And time really flies because it's already 12, and I guess that's mostly it for today. If you have questions or suggestions what we could do, otherwise I'm more than happy to take any suggestions of stuff that we want to explore. So let's just see if we find our country now. So 4 rooms does it have countries? It has USA as a country, right? So, but I expect when I click on USA as a country that it will really explode because it has a lot of movies. But what we can actually do is we can look at our countries, and I give you another trick before we're leaving, which is this network lag is a little bit annoying. Come on. It's also running in Brave Shield. It's probably also not helpful. So it's reloading. Okay, so I wanted to click on the countries again. So because this is sandbox, this is my own sandbox, right? Everyone gets their own sandbox, so I can change, destroy the data, modify the data as much as I want, right? So you can get your own sandboxes as well. So feel free to play around with these data sets. So what I can do with countries, actually, I want to see how many movies each country have. So I can just return n.name, comma, size of, I have an in-country relationship. which goes to our country as degree. And if you run this, then we see each movie and each country, and we can also say order by degree descending. So, and what's actually cool about this is that it uses a built-in capability that you see if I run this with profile, that it calls the get degree kernel function on this. So that means it doesn't actually go over all the relationships to count them, but it actually reads a number from the in-country record, basically, to fetch the size of this relationship type. So it's much faster than going over all the relationships and counting them. So you see US leads, then UK, then it has USA again with a space. So it really seems that my source data from the MovieDB has some data quality issues. So we really need to fix that. Good point. So I should make sure that all of this stuff is fixed as well. Cool. Thank you all for your time. I hope this was helpful and useful, and definitely check out the apoc docs because there's a ton of good stuff in here, and we should definitely help to improve it. So if you spot anything that can be better, feel free to click the edit this page and help improve it. And otherwise, if you don't know how to improve it, but you know that something is missing, please report back your feedback so that we can improve it. Cool. Have a great day. Talk to you next week, and stay safe, everyone. Bye-bye.